shown you a simple one-step unit conversion using English units, and then I've shown you a multiple-step conversion using time. I want to look now at conversion using metric units, and I want to spend just a little time on that because some of you learn to do this by a different method, not by unit analysis. You learn to do it by moving decimals. A lot of you had an acronym. To help you remember the metric prefixes. I've heard a lot of people say, King Hector died by drinking chocolate milk. However, I think it makes more sense that King Hector died by doing crystal meth. So, however you remember it, some of you learned that. And you learned that if you know the base unit, you can switch it to anything with the prefixes. So let's say, for example, that I have 35 centimeters, and I want to find out how many meters that is. The way some of you learned to do this, you said, okay, I've got centimeters, and I want to switch it to the base unit, which is meters, so I'm going to just move the decimal 2 spaces backwards. So you said, okay, 2 spaces backwards, oh, that's 0.35 meters. There's absolutely nothing wrong with that. That method works great, and a lot of times it's a quicker way to do metric conversions. However, that method is not going to be useful to you in other conversions. It's not going to allow you to switch time from hours to minutes or from minutes to seconds. It's not going to be useful to you in chemistry when we start using other units that you're unfamiliar with. It's not going to allow you to switch from grams to moles. It's not going to allow you to switch from grams to atoms. You're going to have to use a different method, and the unit analysis method will work across all of those different types of conversions. So let's do this same problem, but let's do it by the unit analysis method. So we would start with a number that we know, 35 centimeters, and think about what we want to find. We want to find meters. We want to get rid of centimeters, so let's put that on the bottom and put meters on the top. Now, you should all know how many centimeters are in a meter, which is 100. And really in this case, even if you forget, you should be able to remember by prefixes. Centi means 100. There are 100 cents in a dollar. There are 100 years in a century. There are 100 centimeters in a meter. Once you know the conversion, though, you have set this up so it's 35 divided by 100. Now you can see why you move this 2 spaces. Because anytime you divide by a power of 10, you just move the decimal. So when you divide by 100, you have to move the decimal 2 places, and you still get 0.35 meters. Now, some of you are thinking this method was way easier. It got me the answer quicker, it took less writing, it took less steps. Well, I would agree with you. If you know this method and you're doing a simple metric conversion, this method is easier. If you're more comfortable using that, that's fine, but I want you to understand this method because this method is more general, more powerful, and can be used in more situations. This one is very limited. It only applies to direct metric conversions. This applies to any kind of conversion that we want to do. Now I want to show you an example to kind of prove that. So let's go back and use kind of a physics example where you're talking about speed. Let's say that I tell you you have a car that is driving at a speed of 30 meters per second. And I want to switch that from meters per second to kilometers per hour. Now, it's not just meters to kilometers, so I can't just move the decimal. There's also seconds and hours. And you may be thinking, I don't know how to do this. But if you understand our unit analysis method, you do. Let me show you. So when I look here, this is actually a compound unit. I have 2 units in my unit, meters and seconds. I want to switch meters to kilometers. Let's do that first. So to get rid of meters, I put that on the bottom. To get kilometers, I put that on the top. And you should know that 1 kilometer is 1,000 meters. If I were to stop there, I would have kilometers per second. That's not what I want, but it's closer to what I want. Well, I need to do an extra step here. I need to switch seconds to hours. Some of you may know right offhand how many seconds are in an hour, in which case you can do this in 1 step, but a lot of you don't. So let's set this up instead with an intermediate step. Let's get rid of seconds and switch it to minutes. That will get me closer to since seconds is on the bottom, to get it to cancel, I have to put it on the top. And I'm going to switch it to minutes, and there are 60 seconds in 1 minute. So now I have kilometers per minute, almost 2 kilometers per hour. So the last thing that I need to do is to set this up to get rid of minutes and get hours. And there are 60 minutes in 1 hour. So now this is set up. 30 divided by 1,000 times 60 times 60. Well, I'm going to do a little cancellation just to avoid a calculator here for a minute. If I divide this by 10 and that by 10, it simplifies. If I divide this by 10 and that by 10, it simplifies. If I divide this by 10 and that by 10, it simplifies. So on top, I really just have 3 times 1, which is 3, times 6, which is 18, times 6, which is 108. And the only thing left on bottom is 1, so this is 108 kilometers per hour. Now, you for chemistry class, by all means, use your calculator. If you are in my environmental science class, I may have you do some of these by hand. If you take the AP environmental exam, you have to do a lot of problems by hand. It's good to review those rules for fractions. But the main thing that I want you to see is this unit analysis method allowed us to successfully make this switch. It would be difficult to do that using this method. Now, you could use this method for part of it, but you would still have to go back and do your unit analysis method to finish the problem. It's a powerful method. It'll help you solve lots of